Jeez, sorry.
It's okay, it's okay. What were you up to?
Oh, I'm reading a really scary book. It's all about this mad scientist, and oh boy, he's like
A
mixing all these
mad
chemicals
scientist.
together.
Mixing chemicals.
I'm
I
actually
love
kind
it.
of, wow, that was scary. I'm really actually glad you're here. So you're a chemistry teacher, and I'm wondering, when are the kids going to get to, like, the cool things, like when they mix the chemicals in the test tubes and then like stuff happens, like
Yeah.
that's what I've always wanted to do in chemistry. When are we going to learn that stuff?
Well, they did a little bit of it just the other day.
Uh-huh.
They were doing reaction in a bag. But I can show you something really cool.
Okay,
Want to
let's
see
see.
this?
Yeah.
It's, well, what do you see here?
I see water and I see water.
Water. Two things with water in them, right? This water looks normal. Okay. So hold this up for me, Mr. Webster.
I'm a little bit afraid, but okay, I'll hold it like this.
Yes, that looks great. So I'm going to pour this water in.
Okay.
And now I'm going to pour, why don't you take it in close to the camera and really show them. Why don't I pour some of this water in?
Whoa! That makes me not want to brush my teeth with water. What's going on there?
Well, it all has to do with matter. You thought that there was just water in there, right?
It looked like 2 test tubes full of water.
Yeah.
So what's the matter?
What's the matter here? What's the matter? Remember when you guys did classifying matter the other day? We had group A and we had group B, and we classified things. In A ended up all being things that were like pure substances, and then group B ended up being like mixtures. Well, what matter is anything that has mass and takes up space, or we say in science, volume, right? So suppose I have my tennis ball here. This has mass, right? You can feel the mass, and it also takes up space, right? It has a certain amount of space that it takes up, okay? The liquid here that we have, right? It has mass, and it takes up space, taking up a certain amount of space right here.
Sure, I can see that.
Right? And then if I had even a gas, here's my our trusty Ziploc bags that we were using today, and I just filled it up with gas, right? Which also takes up space. It's taking up the space of this bag right now.
Now gas.
So it's matter.
So gas takes up space. So the air that's in this room takes up space.
Absolutely.
And does it have mass?
It has mass.
I don't feel any mass.
You don't feel any mass.
I don't feel it. I mean, I can move my hand around. It's not like I'm touching a table or anything.
Feel that?
Oh, I do feel that.
You do feel that, right? So there is air. Air does take up space, and it has mass.
All right.
Okay. So from there, I want to talk about how we classified our matter into pure substances and mixtures. Okay. And those pure substances that the students came up with, one was oxygen, another one was copper. They had water in there.
Okay.
I'm trying to think of another, sucrose. They had sucrose in their list.
Sugar.
That's sugar.
Right.
Okay. But these substances can be broken down a second time. And I'm wondering if you guys can think about the second way that they can be broken down into. Think about it. There's water in there. And what do you guys know water is made up of?
Well, water is H2O, right?
H2O.
So it's hydrogen and oxygen.
So hydrogen and oxygen are both elements, and when you put them together in a ratio of 2 to 1,
H2O.
Now we're talking about a compound. So your pure substances can be broken down into element and compounds. Elements are substances that cannot be broken down or decomposed into simpler substances by chemical means. And then compounds are composed of 2 or more elements that are chemically combined and have definite proportions by mass. H2O.
I'm glad we're videotaping this, because I'm going to have to rewind that and hear that a few more times.
Okay, so go ahead and rewind if you need to get the definition for an element and a compound. Now I'm going to flip over to our mixture column. And our mixture column had things like paint and laundry detergent. It also had salad and salad dressing. Okay? Now those categories can be broken down 2 more times as well. And we have what are called homogeneous mixtures versus heterogeneous mixtures. And you guys are probably more familiar with what homo means. Right?
Same.
The same, right? And then heterogeneous would be different,
Right.
right? So if you're defining homogeneous mixtures, they're mixtures that have everything is uniform throughout or evenly mixed. So it almost looks like what my 2 substances looked like originally. They originally looked like just water. But guess what? There was a mixture of water and special salts inside of there.
Huh.
Okay, so that was a homogeneous mixture to begin with.
So we had one that was homogeneous.
They were both homogeneous.
Oh, they were both homogeneous.
Right?
Okay.
Because they both look like water, just simply a pure substance.
And then you mix them together.
And then when I mix them together, I got another homogeneous mixture.
All right.
Okay? Because it does look uniform throughout. Okay? Heterogeneous. Okay? Heterogeneous is just basically the opposite of homogeneous. And that means that it's made up of parts with different chemical and physical properties. And these parts are not uniformly mixed or dispersed. And it's like your salad or your salad dressing. You can pick out the pieces. Okay? So I want you guys to think about other things that were on your list when you did this categorizing the other day that would be considered heterogeneous versus homogeneous. See if you can put those different objects into specific groups now. Okay? And then we'll see you tomorrow.